Ladies and gentlemen, welcome to our last presentation like this of the year 2017. Little acids and bases. And what goes better with a little acid-base presentation than some Miley Cyrus? All right. So, acids. You can see here the H in front of the HCl. Big indicator that that's an acid. Sorry, it's supposed to be more background music. And the chemical reaction that we want to look at here is that when hydrogen chloride or hydrochloric acid is in water, it's going to produce this H3O+. So this hydronium ion is something that you saw mentioned in the other two videos. This is an indicator that you just had an acid dissolved in water. And in here, we're going to look at two ways of defining acids. The Arrhenius method as a producer of H3O+, and then also the Bronsted-Lowry method. Here, in this case, HCl is considered a Bronsted-Lowry acid because it donated an H plus to the NH3. So you can see NH3 becomes NH4 plus because this hydrogen right here went ahead and jumped from the chlorine or the chloride onto there. And so those are some definitions of acids that I want you to make sure you can kind of recognize. We pretty much are going to use the Arrhenius method of identifying something as an acid. It's way easier. NaOH is a base. It's an Arrhenius base. This is the common one that you're going to see. In the other video, they talked about how the OH at the end of something is a great way of identifying something as a base. If we look at this same reaction that we looked at in the first slide, NH3 is a Bronsted-Lowry base because it accepted that H+. Again, understand both of them and look at this reaction mechanism that we have going on for both the top and bottom, but know that the Arrhenius method is the one that we're probably going to look at more when we talk about acids and bases. All right, pH scale. Talked about it in the one video. You're going to do a worksheet here in a little bit, possibly even tomorrow if this is Tuesday, or today if this is block day, in which you're going to have to be comparing some of these ideas about H plus concentration, OH minus concentration, and whether something is acidic or basic. Now, pH scale, simply 7's in the middle at neutral, all the way down to 0 being the most acidic and up to 14 being the most basic. You can actually go past those numbers. You can get negative in terms of the pH scale, but we're going to focus on 0 to 14 as kind of being the standard here. On the left-hand side, we have some common objects that would be considered acids and considered bases. I want us to look at these relative ion concentrations of H plus and OH minus. Now remember, H plus and H3O plus are used kind of synonymously, so they mean the same thing. Whether it's hydrogen ion or hydronium ion, they're going to be the same. Notice the difference. Here in the middle, when it's neutral, these are equal. As soon as I move in another direction, towards the acid, you can see that this concentration gets bigger, right? A smaller negative value for the power, and the OH minus gets smaller, right? So as I move acidic, this concentration gets bigger, this concentration gets weaker. As I move towards the basic solutions, OH minus concentration gets greater, H plus concentration gets less. Now you're going to investigate this more with the worksheet that you're going to do, but at this point, just kind of get a basic understanding for this table and what those numbers are telling you.